In modern manufacturing, unplanned downtime is no longer just a reliability problem. It is also a major source of hidden energy waste and can account for 10 to 20% of total industrial energy consumption. Conventional maintenance strategies mainly aim to prevent equipment failure. However, they rarely consider how machine degradation affects energy performance during operation. Predictive maintenance is what helps close the gap between maintenance checklists and real operational performance. Instead of focusing only on preventing failures, it detects early degradation that drives silent losses, higher energy use, lower performance, and reduced stability. By monitoring condition and performance signals, it provides early warnings and recommended actions. Implementation success depends on a structured, data-driven backend integrating reliability and condition monitoring with machine learning to power predictive maintenance. This paper presents the Smart Hybrid Maintenance System, or SHMS. It combines both reliability-centered maintenance and condition-based maintenance with energy performance assessment in a single, integrated framework. At the center of SHMS is the Hybrid Risk Index, or HRI. It links failure probability obtained from reliability models with anomaly levels identified through artificial intelligence and machine learning. This connection makes it possible to quantify both the operational risk and energy impact at the same time. SHMS integrates traditional reliability indicators such as mean time between failures, mean time to repair, and system availability with energy-oriented metrics including the Energy Efficiency Index, energy not supplied, and overall equipment effectiveness. These indicators support predictive maintenance decisions that reduce downtime while improving energy efficiency, cost control, and sustainability performance. The system is fully implemented and operated within the Smart RDM industrial platform. Smart RDM integrates sensor and process time series data, maintenance and downtime records, reliability models, machine learning-based anomaly detection, and KPI dashboards in a unified decision support environment. The approach was validated using the NASA NCMAP simulation dataset and real industrial data from machines connected to Smart RDM. The results show up to a 12% reduction in unplanned downtime and a 7 to 9% decrease in specific energy consumption, together with a measurable increase in energy efficiency. This work demonstrates that predictive maintenance can actively support energy-aware production and sustainable industrial transformation. By embedding energy metrics into predictive maintenance, SHMS improves equipment reliability while reducing energy consumption and supporting long-term sustainability goals.